Okay, so another way that this equation can be used is to solve for temperature. And sometimes you'll get asked questions like, at what temperature is this spontaneous? So we've got two values. We have a H value and then we have an S value. So we've got values here. And we want to know when's that spontaneous. All right, so as long as this term is greater than 0, right? Because if you want delta G to be greater than 0, that's when something is spontaneous. So if I just substitute this in for this side over here, delta H delta H less than T delta S, as long as that is greater than 0, it will be spontaneous. So I'm going to just move this to the other side. I'm going to add this to both sides so that I get T delta S. And then I'm going to solve it for T. So when H over delta S is greater than T, that's the temperature at which that has to be for it to be spontaneous. And remember, this has to go in as a kilojoule and this has to go in as a joule. So my H value is negative 313.5 and my S value is negative 250, and this is a kilojoule, so it's 250 joules times, and that's per mole Kelvin, and in 1 times 10 to the 3rd joules, I have 1 kilojoule. I'm going to put this in the calculator. Negative 313.5 divided by negative 250. But I need that to be converted into kilojoules. So it's just basically that term, divided by 1,000. And I'm going to get at 1254 Kelvin, which is huge, right? But at 1254 Kelvin, as long as my temperature stays under that value, it's going to be spontaneous. So when T is under here. And sometimes it'll turn out when it's like T is greater than a certain value. But the reason that it's when T is under that value is because our S term here being the negative here and then the negative here makes it positive. So as long as this term doesn't get too big, the negative in the H will kind of keep the whole thing negative. The whole delta G value negative.